All right, so in Module 6, we're going to be talking about causal explanations and longitudinal research. So if there's one takeaway I want you to get from this semester, it's that correlation does not equal causation. So every year, you're likely to see somebody post some kind of research online that says that there's a correlation between diet soda consumption and obesity. And I really want to point out that that's just a correlation, not a causation. So people are not becoming obese because of consuming diet soda, but there is a correlation between people who consume diet soda and obesity. And why do you think that might be? Potentially because people who are overweight might want to lose weight, so they're consuming diet soda. I'll say my personal advice is Diet Mountain Dew. It's almost always on my office somewhere. And I get a little bit upset every time I see that study because it's the number one rule in research is that correlation does not prove causation. I'll be delving into that in detail as we move through this module. Chapter 6 of Engel and Schutt covers causation in research design, specifically longitudinal designs. Okay, so this module will hit on three big points. Use of analysis and errors in causal reasoning, cross-sectional and longitudinal designs, and lastly, quantitative or qualitative causal explanations. So some definitions that are important for you to know is a unit of analysis, which is basically a level of social life on which research is focused. So it could be family, individual, community, household, etc. This allows us to interpret statistics appropriately, as measures of association tend to be stronger at the group level as opposed to the individual level. Also, regarding units of observation, is the level of social life at which data is collected. And observation units aren't always the same as analysis units. So the difference between observation unit and a variable, when we're looking at observation units, that could be something like an individual, like a member of a class or a student in somebody's class, versus a variable might be their height or their weight or their occupation or something along those lines. So it's also important to point out two common fallacies within research. So the ecological fallacy is drawing conclusions about an individual level process from group level data. And the flip side of that is reductionism, where we use individuals to make inferences about a group level process. So this is just a diagram to illustrate that point. So if you're taking information about a group to make conclusions about a group, then that's okay. Or if you're taking conclusions about an individual based off of data from that individual, then that's fine too. But this becomes an issue where if researchers are using group level data and use it to draw inferences about an individual, then we've got an ecological fallacy. Versus if we use individuals to make inferences about a group process, then we've got a reductionist fallacy. And I'm sure you could think about implications that you might see in the social world beyond research. It might be something along the lines of stereotyping, for instance, is a common fallacy that a lot of people make. And you should take into account these errors when really assessing the credibility of research design or a research article that you're reading. Because something that's often done within research is taking small sample sizes and making generalizations to a broader population. So really think about the importance of sample size when we're looking at social welfare or social science research. So in order to minimize these errors, when possible, try to avoid analyzing data and drawing conclusions about the same units of analysis. Don't take a case study, for instance, and think that it would be able to summarize it to a broader group or a broader population. And likewise, it doesn't mean that if you do have a sample size that's similar to somebody's demographics, that they're necessarily going to be equal in such variables. So I would just say when reading research articles, kind of identify these errors, kind of view it with a critical eye, as there could be some false conclusions drawn. So next I'm going to be talking about some different types of longitudinal studies. There's a few different here. Repeated cross-sectional design, where we take a sample from a group at time 1 and another sample from the same group at time 2. So maybe grabbing a sample of freshmen from a certain cohort and then grabbing another sample from that same cohort as their seniors, which is probably the simplest of longitudinal design, versus a fixed sample where you're looking at the exact same people at freshman year and senior year. The difficulty here is because there's dropout and it's hard to kind of locate those people over time. Contact information changes. It's hard to store data, and even the people collecting the data may be turned over those years. You can also look at event-based data, so people from the class of 2004, from the class of 2005, 2006, etc., and then looking at them at two different time points. So cross-sectional design can tell us a lot about people at a specific point in time versus longitudinal design can tell us about certain things that change over time. So for instance, if we're to look at cognitive functioning over time, we could take a group of 60-year-olds now and a group of 80-year-olds now and see how they differ on cognitive testing. Or if we were to do a longitudinal design, we would take those 60-year-olds and measure them now and then wait 20 years to measure them again when they're 80, which you could see that could be a lot more costly and a lot more difficult to do, but also a lot more beneficial for research and kind of accuracy of the data that we're looking at. So you'd use cross-sectional if the independent variable is fixed prior to the variation in the dependent variable. So maybe the independent variable is era served, like if we're working with veterans looking at OIF, OEF veterans versus Vietnam era versus Korean versus World War II. That's where the independent variable is fixed. You could also use cross-sectional designs if the respondents are trusted in their account of previous events that's pertinent to the study. And when we also have data from pre-existing records or measures that are based on records containing information from different points in time. Or contrarily, if subjects are equivalent on the dependent variable before the independent variable was introduced. So maybe people who have similar mental health diagnoses screened before an independent variable of some sort of intervention was introduced. Then you could use cross-sectional as opposed to longitudinal. So you use longitudinal data when you want to track changes across time. So pretty much any time that you're trying to show causality, you need to measure something across time. Cross-sectional can give you an idea of causality and like how an independent variable may have an impact on a dependent variable. But generally longitudinal studies are the better option for getting you some strength or evidence of a causal relationship between two variables. So in a trend study, we want to collect data from multiple times from different samples of the same population to determine if the population has changed it over time. So right now I see so much studies about millennials and like trend studies about how that population is changing and what they do like and what they don't like and their behaviors throughout time. So that's a good example of trend studies. Also, there's panel studies that collect data multiple times from the same sample of the population to see if those individuals have changed over time. So you might look at valid Victorians of high schools at a certain point in time, maybe in 2004, and follow them across the years to see how they're faring later in life. And that'd be like a panel design if you looked at those same group of people at point A and at point B. So maybe people who did like a reintegration program after they got out of prison and seeing if they were able to integrate back into society seamlessly or if they were repeat offenders. Cohort studies are like an event-based design, so maybe graduates of college in the year 2007 or looking at cohort studies, so maybe like baby boomers across the lifespan to see maybe different indicators of quality of life across the decades. So now that I've talked about what we're doing to look at causality and ways to measure causality and to kind of investigate it, basically what a cause is just an explanation of some characteristic, attitude, or behavior of a group, individual, or other entities. So a quantitative, nomothetic causal explanation is the belief that variation of independent variable will be followed by a variation in a dependent variable, all else being constant. So if we change from regular Coke to Diet Coke, where there'll be a followed up change in the outcome of body weight over time if all other factors being diet and exercise pretty much remain constant and the same. Versus a qualitative or idiographic causal explanation basically is the identification of a concrete individual sequence of events, thoughts, or actions that result in a particular outcome for a specific person or event. So typically this is less done in like a research, more of experimental way that the nomothetic explanation is. The idiographic looks at case studies and just wants to get like a richer investigation of what it's like to be that one individual within that space of time without really trying to manipulate anything, just kind of observing and getting to know more without really leading them in any one direction. So criteria for nomothetic causal explanations, there should be an empirical association. Oftentimes these are done with like standardized measures that look at statistical relationships between two variables. For any kind of causal explanation, there needs to be a time orderness and also the assumption of non-spuriousness. So you can see the asterisks show that empirical associations, time order, and non-spuriousness are all necessary to demonstrate causality, versus causal mechanism and context are convenient but not necessary for causal explanations. So empirical associations and time order. Empirical associations is when an independent variable changes, the dependent variable also changes. So if there's an empirical association with a certain intervention, for instance, if we said CBT for depression, when we introduce CBT, we should also notice that there's a change in somebody's score on a Beck depression inventory as the dependent variable. And regarding time order, when variation in the dependent variable occurs after variation in the independent variable. And through time, we can show that with the introduction of the independent variable, we can see ultimately the dependent variable will change, not just at one point in time, but through the course of time. So kind of back to sampling, through randomization, we reduce the risk of spuriousness by decreasing the likelihood that the treatment group is governed by some type of third variable. So what that means is if we're picking a group of people based off of convenience, maybe that group of people had something in common. So if we're looking at maybe like a parenting skills group, if we were to pick a random sample or a convenience sample, like the first 10 group of parents that came, maybe those parents are probably higher functioning to begin with, versus if we picked a random sample from a census or random digit dialing, then they would be less likely to be more responsible just by the nature of signing up first. And also an important concept here is statistical control, which is basically a method in which a variable is held constant so that the relationship between two or more other variables being assessed without influence of a variation in the control group. So when we conduct research in social science, we want to control for external variables as much as possible. So for instance, if we're doing a smoking cessation group, one person got a nicotine patch and then another person got a placebo patch. If we knew that the person with the nicotine patch and the placebo patch were actually roommates and either sharing information or sharing patches or whatever it may be, that would be a threat to the statistical control of the study. And there'd be so much noise in the data that you wouldn't really be able to show any kind of causality of smoking cessation associated with the nicotine patch. So just a definition, the causal mechanism is what creates a connection and variation between the independent and the dependent variable. It's not the consumption of diet soda that causes obesity, even though you might see people arguing that in some bogus research articles that you see online, quite frankly. But you could show a causal relationship between exercise and weight loss, because throughout time, if we're introducing exercise, we're certainly going to see loss of fat. That way we could show a causal relationship over time. And another definition is just to be aware of context and that all relationships exist in a broader context with other variables. And that's what makes social science a lot more difficult and rigorous than natural science, because there's so many variables that we have to control for because of the context that people live in. So when coming up with a research design, we have to think about the overlap between research problems, what kind of opportunities for research there are, prior research that's already been conducted, our philosophical commitments, and our research goals. There's a lot of factors that go into determining research design, what kind of questions are going to be asked, and how it's going to be conducted. And the implications for evidence-based practice is based upon the understanding of the implications of the research finding. The more we know about the research design and what it actually shows, the better we can apply it to our practice. So, for instance, I mentioned CBT for depression. There's been a plethora of research showing that CBT is one of the better interventions for treating individuals with clinical depression. So through a number of studies that have kind of shown causality, maybe in a controlled environment, whether it be an inpatient or residential environment or even outpatient environment, we've got enough people with longitudinal studies to show that it's one of the better, if not the best, interventions for treating clinical depression. So based on that type of research, then we can make a strong argument why it should be applied for an individual who does meet the clinical threshold for depression. And that leads to implications for evidence-based practice and best practice for our clinical work with individuals that we're serving.